Howdy, this is Jim Rutt, and this is The Jim Rutt Show. Listeners have asked us to provide pointers to some of the resources we talk about on the show. We now have links to books and articles referenced in recent podcasts that are available on our website. We also offer full transcripts. Go to jimruttshow.com. That's jimruttshow.com. Today's guests are Fernanda Ibarra and Art Brock of Commons Engine and the Holochain projects and various other things. Got to ask you a quick question here before we go on. I'm actually reading a book called Free, Fair, and Alive, The Insurgent Power of the Commons. Have you ever read that book?
Yes, not only read that book, but David Bollier contacted me to help them to work on the Holochain section, and Commons Engine is mentioned there. And then I spent a whole week with them in Germany working on ontology and patterns for the Commons. So yes, read it.
That's great. And as usual, listeners, we will have links to everything we reference, whether companies, websites, books, papers, on the episode page for this episode. So don't feel like you have to take notes. Just go to the website, jimruttshow.com, and you'll have links to everything we talk about. That book, I'm about 20% in. I'm quite taken with it. I'm reading it slowly and carefully. So I guessed there was probably a relationship with that. You know, Art has worked to unlock the secrets of the social DNA by which people operate and the critical role of currencies for programming these patterns. He's also designed lots of currency systems. The list is almost endless: scientific research, fishery management, stock options, community-based economic development, etc. Fernanda has started off in the area of collective intelligence, which is certainly of strong interest to our audience. She then began working in communities of intent, intentional communities, we might call them in our space. And there she realized that money, or we would probably abstract a little bit and talking about the social system signaling that is like money, was critical. And she and Art and the other Holochain guys found each other, and I think that's how we are today. So let's jump in a little bit first and talk about Holochain itself. We'll then later talk about Holo, Holoport, HoloFuel, the Holo token, etc. But let's talk about the Holochain itself. As I was doing my research, one of the analogies that y'all used I found very illuminating, which was describing the Holochain approach as agent-centric rather than data-centric as compared to, say, Bitcoin and Ethereum. And in particular, you compared Holochain in ways to Git. Could you start with talking about agent-centric computing and how that's fundamentally different than what Bitcoin and Ethereum are doing?
Sure. You know, the thing that there is in common is that we use hash chains, which, you know, is a cryptographic structure that can give you essentially some characteristics of immutability where you can't really go back and change the past once hashes of things have been shared, right? So it kind of locks in the past. So there's kind of the common ground. But one of the better ways to think of Holochain less like blockchain than like Git plus BitTorrent, right? So instead of managing consensus of what blocks have been committed officially to one ledger, every agent has their own source chain, we call it, because all data is sourced in a source chain. And it is only the data they author, their local state changes that are written to that chain, and then published to a DHT as the shared ledger global visibility space. But that's an eventually consistent system. It's not a consensus-driven system. So that makes for very different characteristics of performance. And I would assert it actually models the way the real world works, the way we see things work in physics and biology. And hence some of the naming of things in Holochain, like application code is called DNA, you know, things like that. So it's a pattern that is inspired by nature that gives us the scalable coordination.
Yeah, one of the things that struck me immediately, and those who've listened to this show before know that I will rant about Bitcoin and how the main thing it's doing is accelerating the heat death of the universe, right? You know, it strikes me that, as you say, most real-world problems don't actually need to be written to a global ledger, right? That everybody in the world has to duplicate, et cetera. take Ethereum's case, it's even more absurd than that. It's essentially saying every computer program in the world doing class X of application, in the case of Ethereum smart contracts, has to run on the same slow computer. Who in the world would design a system like that, right? And yet those are two of our more popular distributed ledger applications out there. And as I dug into Holochain, I said, this looks like it might actually scale and be a reasonable fit for the real world.
Yeah, if I could say a little bit more about the agent-centric aspect, I think distributed computing gets a little hung up by traditional computing in terms of we're used to thinking that we can hold the whole data set, the whole data space, right? And that space has sort of its own inherent truth to it. This is the kind of data-centric mentality. And what we're suggesting is all of that data actually came from somewhere. Whenever it was created, it was an assertion by an agent. And if you break that from its provenance, if you break data from where it came from, you actually have already lost data integrity. If you were to ask me what the temperature in the room that I'm sitting in right now is, there's a thermostat over on the wall that would give you one thing. But if I had one of those little infrared devices and could measure different temperatures, I'd, click it over the lamp over there, that kind of thing. It would get lots of different temperatures. And then if we wrote those to a database where Arthur used this device and I signed them to a database, but then we find out tomorrow that infrared little, gun trigger that I was using to measure the temperatures is 20% out of calibration. Now we know which data was affected, which data is not true. When you just start off assuming that data has sort of inherent truth and you break it from where it came from, I'd suggest you're starting with problems. So Holochain is really coming from this agent-centric perspective that you write data to your chain, it's signed and shared, and so you always know where the data came from. It can always be verified and validated against that local state.
Okay.
And so that just lets us create very different kinds of patterns of sense making and social coherence that I would say go far beyond kind of the current scope of smart contracts and such.
Okay, so let's, for our audience, we'll break this down into more bite-sized pieces. So when I start to develop something or start to be a user of Holochain, I have a private key, and I use my private key to sign additions to a local blockchain called the source chain. Is that correct?
Well, not a blockchain, just a hash chain, but yes.
But I read it. It looked like the math was pretty damn similar, right? But okay, let's call it a hash chain. So we use the same trick that you sign the block, including the previous signature, so it can't be hacked, etc.
Yep.
What do you call each thing that you write? What's the name of the block that is written to the chain?
It's just an entry, like an entry in the database or whatever. We just call them entries.
Okay.
Rather than being a block of many entries.
Great. And of course, one of the nice things about that is that you don't require expensive proof of work to have the right to write to your source chain. Presumably, the only credential you need to write to your source chain is your private key.
Exactly.
Okay. Now, of course, this gets me into one of the great bugaboos of our whole world, which is private keys and the management thereof. Have you guys done anything to help with that problem?
We have. So Holochain has an API we call DPKI for distributed public key infrastructure that actually uses a Holochain app in the background as a key management infrastructure so that you can revoke or replace keys. Because right now in the blockchain world, if you lose your key or if your key gets compromised, somebody else gets hold of your key, you've lost your tokens or you've lost control of your smart contract or, whatever the thing is. And in the case of Holochain, if your laptop gets stolen and you had some Holochain apps on that, you could use another device to revoke those keys or replace those keys with new ones and resume control of your identity, essentially, of your agency because of having key management in place.
That's very good and very important because, again, one of my people have heard me rant about this before. One of my critiques on traditional blockchain applications utterly dependent on your private key, and we already know that some non-trivial percentage of bitcoins are probably lost forever because people died or lost their private key. In fact, I actually have some very early Bitcoin that I have lost. Back in the days when you used to be able to get a tiny fraction of a Bitcoin Bitcoin for sending a text message to somebody. It was hilarious. I probably have a thousandth of a Bitcoin somewhere on one of my dead computers that nobody will ever see again. So we get what we called intrinsic data integrity by signing each element, each entry going, and then you write it into your local chain. But you guys make a big deal out of the fact that private data by itself isn't all that interesting. Why don't you guys riff on that a little bit?
Sure. Actually, if I could even just touch on the intrinsic data integrity aspect of what you were just talking about, blockchain has been kind of blown up to be about tokens and about currency. But I think what's interesting is it's about anybody being able to hold and serve the data, because the data has intrinsic integrity. You can tell that it hasn't been tampered with, right? And so in the case of what you're talking about, we can actually have shared sense-making spaces and trust each person or anybody on the network to be an authority for the data. So what I mean by that is, like, who wouldn't love to be able to log in and change their bank balance? You know, say I've got $5,000 more today than I did yesterday. Well, the thing that prevents that in this story is that you can't tamper with the data. The data is tamper proof. There has to have actually been a transaction that somebody else signed for that money to exist, right? And so all state changes are signed by the people whose state is changing. So in the case of implementing a currency on Holochain, which doesn't have one built in, by the way, like most blockchains do, we recommend you do it basically like double entry accounting. And the two agents whose state is changing both sign the same transaction to each of their chains, and they give each other the counter signatures. And then you have local state changing, and you don't need global state or global time to be able to make this work.
We'll go into that application, that a particular small scale currency application a little bit later. But when we have our data written to our local source chain, it's not all that useful sitting on our own computer. Probably some things would be all right. Maybe I want to do a catalog of all my DVDs or something. But if I want to share it with people and build online environments that do actual work, you need to replicate or get that data out so other people can have access to it. Now, of course, this is the tricky part of distributed computing. In Facebook or something, all the data is written in one place, or at least it looks like it's in one place. It's easy to search. It's one big, from the user perspective, bag of searchable data. Much more tricky in distributed land. You guys have the idea of peer replication and validation. Maybe you could describe that a little bit. And how do two peers decide to peer with each other?
So in Holochain, each Holochain application is a separate network, if you will. It's a separate peer-to-peer encrypted network. And you have to be running the same application to be a peer of others. So for example, if you take a chat app like a Slack application and you want to create a private Slack team, you could fork an existing instance by just changing a little number in there, changing a UUID in there to make your own little network that has its own identity, and send people an invitation code to join your network. And they become peers in your network by installing that software, installing that instance of the Slack app. And then the one trick there is a bootstrapping process for peers to start finding each other. So you would need to give an address. And right now we're stuck using kind of the centralized domain name resolution type process for addresses just because it's universal. So that's kind of the one little legacy part of centralization that's in Holochain, is that we have to bootstrap somewhere. And then the peers just gossip with each other to manage the sharing of that information of the Slack chats, for example, or of a Twitter and that kind of thing. And so much of the internet now is Web 2.0. It's data that is contributed by the users, and yet that's all given to some central corporation, when there could be ways that we could just hold these things ourselves without needing to basically have a surveillance corporation in the middle that's making money off of selling your data to advertisers.
And we know there's a lot of interest, particularly in our Game B world, of getting away from these centralized data controllers and exploiters of users, right? As we say, if you're not paying for their service and you are the product, right? And you're basically, your attention's being hijacked in various pernicious ways. And if we had control of our own data, we could get away from that. So to make it clear, what peering really means is that multiple people, two or more people, are using the exact same app, which means that the app itself is signed, right, and owned by a private key or an address. Is that approximately correct?
Yeah, the app code is actually signed into the first entry of each person's source chain. So if that source chain doesn't start with the same hash, then you're not running the same code. You don't have the same rules because of the peer validation you talked about. We actually have to be able to check each other's work, and that has to be reliable, which means we have to have the same rules for checking each other's work, right? And so that's actually the very first entry of everybody's chain. So you can check that hash and make sure we're all in the same rules. It's also part of the network encryption salt so that you're not even talking with somebody that doesn't have that hash and isn't in that encrypted network.
Okay. Now, one objection I have read about that is that means that every time you do even the most rudimentary bug fix on an app, you essentially have to have everybody, fully reinstall the app. And in fact, in some real sense, it's a different app. How do you respond to that objection to this architecture?
I would say that is a real phenomenon of distributed software. That objection comes from a centralized software viewpoint where everybody has to go to one authority, and that one authority is managing everything, and therefore you can just change it in one place, nice and simple, right? But if it's distributed software, then the people running it have to receive a new distribution of the new version, right? And be able to move to that new version. Part of what we encourage in Holochain to reduce the pain of this is, first of all, not making huge monolithic applications, but instead building small microservices that work together and have pretty reliable, narrow functionality. And you keep in the DNA, you keep only the data integrity management, the data validation and integrity management rules. And all of your UI stuff should be outside of the DNA. And you can change that stuff, and people can be using different versions of UIs, and that's fine. They'll still have the same peer validation for checking each other's work.
That brings up a very interesting question. Let's say it is a distributed Slack channel. If the app changes, i.e. the signature on the app changes for, let's say, even a fairly rudimentary bug fix, does the data have to be re-replicated as well, or are the data and the app some set separate on my machine? Let's suppose I have 2 years worth of Slack data for a 50-person project. Could be a lot of data. When the new version of the app comes out, does all that data have to be replicated too?
Great question. So it really depends on which type of app it is you're talking about. And what you can do with Holochain, the apps being microservices are small and lightweight, and you can be running multiple versions of an app if need be. So one of the things that we do to address the simplifying the kind of the pain of having to have everybody migrate from one version to another is that we have this sort of concept of closing entries and opening entries on your chain where you can say, okay, I'm closing down working on this version and have migrated to this new DNA. And in that new DNA, after your first entries where you put in the DNA code and your agent key, then you can have an opening entry that says, I just came from this other DNA hash. And that way you can actually have queries that span across DNA versions and across DHTs where you can be running them both or running multiples and be querying into your history across multiple versions. And so that we can try to provide as seamless an experience as possible there.
I can see that's going to be a little tricky from a application development perspective. In fact, I interviewed Stephen Levy a couple days ago, who recently wrote a great book about Facebook, right? And one of the things we talked about, one of Facebook's competitive advantages was it was one of the first major online companies to be essentially built with DevOps in from the very beginning, so that they were pushing 4 or 5 new updates to the Facebook software every day. And we know, of course, now Google, nobody sees the same Google. Everybody gets a different Google because they're testing hundreds of different parameters on the user interface every day. And it strikes me that hyper agile, DevOps driven, user experience driven way to evolve software incrementally would be impossible to do in this environment.
Well, except as you said, most of those changes are to the experience, to the user interface, not to the underlying data integrity. So it's only when you're changing the underlying data models, data structures, or the permissions and such that would affect validation that you would actually be changing the DNA. You could have many, many different versions of UIs running. And in fact, part of the beauty of it is you could allow, again, it's sort of an agent-centric perspective on this, where I could customize my own UI or run my own skins or pull different data from different applications into a single UI that don't provide that kind of unified interface. And because what matters from the DNA perspective is that no state change is happening that is invalid. But you can collect that data and display it however you would like.
Yeah, though in the case of Google in particular, and Facebook as well, there's sort of a deep marriage between the data and machine learning algorithms, which decide how it's presented. And from the UI layer, those two things kind of live together. And it's the machine learning layer that's evolving probably even faster than the formal UI.
Exactly. But you would put that machine learning layer for the UI outside of the DNA. It doesn't change the structure of the data necessarily. It just will filter which data, like rank which pages come in your search or which posts in your feed and that kind of thing. And this is, again, the beauty of I could use one algorithm and you could use another to display your feed. And we could each get what we want that way. Where right now on Facebook, we get what Facebook and its advertisers want.
Exactly. I call it the Zuck algorithm, and I hate it, right? If you can actually pull that off in a way that really works for real developers of application, then this may well be the right platform to replace Facebook with at some point. Let's go down a little bit into the weeds a tad. As I understand it from my relatively modest readings, the actual applications are created out of components called zomes, which are lower level components, which are then packaged in a way that are not that different from microservices called DNAs. Could you talk just a little bit about the distinction between those two and why you chose to do it that way?
Yeah, zomes was just kind of our silly word for modules based on chromosomes in DNA, right? Like, what are some of the subsections? Well, how might you modularize your code? Because generally speaking, people want to create good modularity for sharing and maintaining code and reusing portions of things. And so the idea is a zome may be a module or reusable portion that you might use in different places. So for example, there's an anchors pattern that you use a lot in Holochain where you sort of use a predictable bit of content to hash. Let's say it's a username, and then you can use that hash to attach a lot of links to find other things. So if it was a Twitter app, it could be your Twitter user handle, right? Your Twitter handle. And then from that handle, I can find links to your posts, to your tweets, right? Or to your followers or to who you're following or your favorites or, things like that. And that handle holds a lot of things together. Well, there's an anchors API or an anchors mix-in that a lot of applications use. And that's a zome that they can just plug in and use this pattern for generating anchors that also create kind of a little directory system and a way of kind of having data be more discoverable, because on a DHT, data is tricky to find sometimes. If you don't know the hash, right? How do you go look for it when it's spread across potentially thousands or hundreds of thousands of computers?
Yep, we'll talk about that. I can have a whole section on that. Going the next level. So we can think of zomes as modules and DNA as the equivalent of small programs. Is that a fair enough way to describe them?
Yeah.
Okay. And then the next level up, I believe you call hApps, is a bundle of a client which talks to one or more DNAs using a lightweight RPC. Is that approximately correct?
Yeah, a hApp is a way of bundling DNAs and UIs into something that basically can be delivered to an end user. There may be a single UI, there may be multiple UIs, there may be multiple DNAs, but it provides an integrated, a singular experience by bundling it all together.
And as we know, in a lot of real world problems, building that UI is not easy. Do you guys have decent tools for building UIs at this point?
We have had a few different iterations of tools, and I'm actually very excited about one of the newest ones that's coming out of one of our guys, Philip in Australia, who's been building a bunch of components in Vue using the Vue JavaScript framework. And he's been building a Holochain app designer that is a Holochain app. So Holochain essentially replaces GitHub in this way where you can actually use it to manage and share designing information while you're building an app with other people building the app. And then there's this mode he's calling a Chimera mode, which, is like a mashed up animal, if you will, part lion, part snake, part whatever, right? So it's kind of a mashup mode where you can pull different DNAs together, and he's defined slots where you can have the UI components, the web components from one UI sort of populate into another one, and you start having this kind of pluggable componentry for UI components for Holochain apps. And hopefully we'll be publishing this in the next couple of weeks, because I think it'll be a fun thing for people to play with.
And those things matter. I can tell you as my business career, I did various things. I was an entrepreneur. I was a, sole entrepreneur, startup venture dude, all that stuff. Then I was also a corporate CTO for a number of years. And one of the things I saw in the 90s is sort of the Microsoftification of corporate American software was driven by one thing: Visual Basic. Oh my God, right? Because it was easy, right? And they, worked off that and built a whole, Visual Studio, et cetera, et cetera. And so I would not at all underestimate the criticality to your ecosystem of having tools that are easy, indeed even pleasant to use, to be able to build, the whole stack out. And I hope you guys are paying enough attention to that. Because my experience, a lot of people in this space aren't.
Yeah. To me, what Philip has built is a bit of a breakthrough for us in it. We actually did have a scaffolding, kind of a quick start thing that would almost like a wizard help you build your app kind of thing, where you would identify your zomes and some entries and create entry schemas for you using JSON schema and all that kind of stuff in the old version. And it would generate tests and a basic testing UI, ugly, but basic testing UI, and also your basic CRUD functions for the data. You still needed to go in and do more with the peer validation rules and everything. But in terms of like bootstrapping somebody up quickly, it was a really helpful tool. And this one was supposed to be kind of the successor to that. And Philip went a little crazy and just started getting into, mixing and matching all the visual components as well. And I'm really hoping that it does create some buzz and stir, because it's the kind of thing where power users can start assembling apps and combining pieces of apps into new things and that kind of thing. And you don't have to be a power developer. You can really kind of be a power user that can paste things together. And I would assert that much of the web emerged that way, from kind of people pasting together stuff that they found on other websites and liking that pattern and assembling it together, right? That's kind of how we got to where we got to on the web altogether.
Yeah, I used to make that point that even though, from my perspective as a former database designer and network protocol aware dude, I can't imagine anything sleazier than HTTP and HTML, right? Holy shit, who'd want to build a world on that? But the reason it happened was you could tell your secretary to go view source and steal the source from an early 1993 web page and duplicate it in 15 minutes, right? That's why HTML, HTTP took over the world, despite the fact that it's an abomination, right? It was easy. It was viral. I guess, though I suppose we're not supposed to say viral anymore in this time of pandemic. And so, yeah, those ecosystem things make all the difference in the world. It led us to this horrible thing called the web, which is now not so horrible anymore, but frankly, despite its foundations, not because of them.
what I'm hoping that it accomplishes is actually understanding that Holochain apps can be very small in scope. They can just be your family's check-in system, or, something with a small group of people, where blockchain apps tend to be viewed with much greater sort of weight and significance, because you're kind of like writing something in stone forever on a monolithic blockchain. If you make a mistake in your smart contract, it can be horrifying and have real financial consequences in terms of gas costs or credits lost, or, different things like that. And part of what I'm hoping can come out of a tool set like this is losing a little bit of that stigma and fear and significance, to just say, oh, I can just invite people to play in little spaces. And the risk factor in that is extremely low. It's just sandboxes we can play in.
Yeah, and I can revoke the program if I want to, right?
Yep.
Right. That's with your key management system. I can just kill that sucker, right?
Yep.
Let's move on to the next part. And frankly, as a database nerd, the thing I found most interesting, I'm not sure everybody will, but I thought it was really cool, and that really, really serious innovation is your distributed hash table. And particularly some of the interesting ways that you made that tolerably efficient, such as basically making everything a hash, including usernames, and basically assigning content to the agent's name who's closest to the hash on the content, etc. Could you lay out for the audience what is a distributed hash table and why is it interesting and innovative?
So the just starting with the real basics, a hash is kind of like a fingerprint for data. And if the data changes, the fingerprint should change significantly. A hash table is kind of a way of organizing that in a key value store, where the hash is a kind of key that you can look up the values you're looking for. You can retrieve the values you're looking for in a table. A distributed hash table divides that across many, many different machines so that nobody needs to hold the whole thing. So it's a way of breaking a kind of database into many little parts. And then when we do that, we can also have agents or users have addresses in the same address space that the data is stored in. So now we can arrange the data. We can send it to hosts whose address is near the address of the data. And so whenever you're looking for data, you just sort of get routed toward the hosts with the closest addresses, or the peers with the closest addresses, and get back the data that you're looking for. And so we can set up some redundancy levels, and we can set up gossip and things for being able to have peers that are near each other know about the data that each other are holding. And so we can have kind of a self-healing database. As peers drop off the network, the other peers near them gossip it, more broadly. And as new peers join, they learn about the data in their neighborhood and get that gossip to them. And so it lets us have kind of an organic, living, self-healing database, which is, I think, what we have to have in these sort of peer-to-peer driven systems.
Now, if I'm building an app, can I set parameters on about how much sharing I want? Because when we do distributed databases, I occasionally fool around with Apache Ignite, for instance, and it's a very cool distributed database system that does automatic replication. But you can define the replication rules. Like, can I say I want at least 5 copies of every entry, or is it less well parameterized than that?
The plan has been that you set a target redundancy level. And I say has been because I think it may be changing a little bit as we learn from actually trying to run these distributed systems. Individuals don't tend to know much about the consequences of that decision that they're making, right? When they say, well, I think there should be 100 copies of the data on the DHT, right? Well, first of all, because of the self-healing nature of it, what we're trying to do is manage how many copies are online at any time. Meaning, when peers are gossiping with each other, they're keeping a little log of my attempts to reach you, what percentage of them were successful, or what percentage of them failed, so that I have an uptime estimate for you, right? And then I know that if the target number here is 100, but my peers really only have 25% uptime, right? Then basically I need to have 400 copies of the data alive, yeah. Right? And since people don't know that they're making that kind of decision often when they say 100 copies. Now you have 400 nodes trying to gossip data around, which slows the whole system down. And what we're kind of finding is that we may want to have the default be a kind of autopilot mode where let the network balance itself and make sure that there's adequate redundancy and adequate load handling, rather than have sort of a preconceived notion of a single number of redundancy factor be able to provide that. For now, we still have that single number as the target, but I think we're going to be tuning this more kind of like auto-tune mode where we can have applications default to auto-tune and only override that in kind of exception cases.
That's probably very wise, again, to help people who want to just try things, right? Because you are absolutely correct. Trying to actually understand a distributed database and how you should configure it is a problem of nightmarish proportions, even for people who know about this stuff, right? Exactly. And as you say, even relatively small changes in parameters, when you run across the combinatorics of a distributed database, can have really big implications. I'm going to take a little sidebar here, something I was going to get to later, but you've mentioned the gossip protocol that you guys use a couple times. Gossip protocols are a class of protocols. There's lots of gossip protocols. It might be useful for our audience who probably have never heard the term before to explain what a gossip protocol is, and maybe at least a little bit, what are some of the specifics of your protocol?
Cool. The basic gist, gossip is referring to the same kind of activity that we as humans do. It's kind of like, hey, what's new? What's the news that you've heard? And so in a gossip protocol on Holochain, you connect to other peers and you may have things to deliver to them that you're intending to deliver to them, like saying, hey, you need to know about this. But then you're also asking them, hey, what have you heard about that I should know? And in Holochain's DHT representation, we're able to have a very simple representation of what data a node is holding. There's their address, and then there's another integer, which is basically the range beyond their address that they're holding. So it allows nodes with higher capacity to hold more and nodes that are maybe smaller capacity running on a Raspberry Pi with very little storage attached or something to hold less. But we have a simple way of knowing what range you're accountable for of addresses in the DHT. And so we can say, for my range, given these two numbers, you know about me, you know about my address because it's literally the address I'm contacting you from. My message is signed by it. It comes from that address. And all you need is this one other number to know whether or not any of the stuff that you're holding or new things you've heard about are in my range that you should tell me about. I hope that kind of is the crux of the gossip protocol. And then nodes are just doing this on a periodic basis, depending on how frequent they're seeing new data. And the less active applications can calm the gossip a little bit because the changes aren't happening very frequently. And very active applications are going to have faster gossip because there's a lot of changes happening.
And can you specify that at the application level, essentially?
At the moment, what we're doing is, again, we're trying to get more into this auto-tuning and more like exponential backoffs, where if I haven't gotten anything new from you, then I wait a little bit longer and and then if I start getting new things from you, then that kind of pulls me back into a very active mode, and then we kind of back off and calm a little bit. So that's more built in to the system auto behavior at this point.
Okay, let's move on to the next topic, one of my favorites, which is hashes by definition are cryptic links. They provide no information at all about the data, right? Because if they did, they wouldn't be a hash. However, in an information system, we often want to be able to query on the content, right? And at first I said, oh, damn, another one of these stupid databases of cryptic links. That's pretty damn useless. But then I dug a little further into your materials and I realized that you've extended the concept some towards a graph database with what you guys call tags and anchors that make it at least feasible in principle to allow some traversal of the graph that has some content specificity to it. And of course, this is a famously difficult problem, right? And I'll just stop there, actually, let you talk a little bit about how you make this graph of cryptic links into something that's at least somewhat searchable.
Yeah. As I mentioned earlier, it can be very hard. You can't expect to crawl a DHT because by the time you even got around to people that you knew existed, other people might exist and other data would exist. And there's not really a good way. It is inherently kind of an eventually consistent space. What you want to do is build good ways of finding the data through references. So those references can be in the form of links, or those references can be in the form of indexes, or those references also can be in the form of chains, meaning we already have one topology that every piece of data that got added to the DHT was in somebody's source chain. So I could find from one of your neighbors, I could request kind of your header history if you were offline and basically be able to crawl your activity, your set of state changes. That's one way that we can find data on it, right? So if I have your key, your address, I could talk to neighbors of yours and say, hey, give me this header history. And that's really useful for things that matter in a chronological context, things like monetary transactions, right? That's whether your current balance is based on the chain of your past actions, which funds you've received and which funds you've spent, right? And so that topology already exists. But what we've done, like you said, with links, is be able to attach links onto essentially anything else and query them as meta information. And then we have this pattern of anchors, which is a way of giving links a good base to attach to that's predictable and known, like a username or something like that. And then we even have created the anchors in a sort of tree hierarchy so that you can think of that like a browsable directory file structure, if you will, where there's a root anchor that tells you what anchor types exist. And those anchor types tell you which anchors exist. So if there's a user anchor type, you could kind of get the list of usernames off of the user root anchor, and so it creates ways of having the space be discoverable and crawlable and still be distributed.
Yep.
Indexing is a whole other problem.
Yeah, that's a good first step. However, as we know, there's a big tension between browsing and searching. And the way I would describe it is that the problem with browsing is that it puts a burden on somebody to manage a taxonomy. Right. And if we remember to the early days of the internet, Yahoo was actually a taxonomy. You browsed Yahoo. You didn't search it in the old days. You went down these damn menus layer after layer. And then other people, Lycos might have been the first one that was an actual search engine, or I'm not quite sure. But anyway, you could actually do full text searching. So this is the indexing issue. And, to bring it back to a tangible example, our old friend Facebook, love it and hate it. You go up to the Facebook search box and you type in almost anything, and it's surprisingly often it'll give you what you're looking for. How do you do indexing? How do you do something like search on a distributed hash table?
I think there's going to end up being a number of different indexing strategies. But one of the ones that we were using in the Go version of Holochain and the apps that we built there, I think is carrying over in this Rust version, which is basically that there's an indexing app, another Holochain app, but that it's only being run by nodes that are more substantial nodes that are online reliably, that have storage space and processing power. You could think of those as servers. Because we want, generally speaking, Holochain apps to be lightweight enough for you to just run them on your phone. And from the graphing perspective, we can keep that in scope and not put too heavy load on somebody's phone or something like that. But if you start running indexing, and this is a peer-to-peer app that everybody's running, now you're getting back into the sort of blockchain problem of everybody holding everything, right? And holding an index to everything, or at least holding an index to everything, right? So because Holochain Holochain apps can bridge to each other locally, what we can do is you can build your Twitter app kind of thing, but now you want those tweets to be indexed. You want to be able to search on, emerging terms and that kind of stuff. Well, then you can have some nodes be index nodes. We can get into the incentives for running an index node in a minute. But the way that that works is the index node runs the Twitter app. In our case, it was called Clutter. And they also run the Clutter index app. And they register themselves in the Clutter app as an index node. And then everybody, when they posts to one index node. And the index nodes gossip with each other because it's a Holochain app that's gossiping, right? And you can do queries by sending a direct message to an index node and get back a set of results, and then just query your Twitter app, your Clutter app peers for the actual things the results you need to load, but you get the results list back from one of the indexes. And we built that index pattern using anchors, just using keywords as anchors that then had links that went off to the posts that included those words. And, so everything that we used in that pattern, we've already kind of described on this call. But that's going to have a certain level of performance. That whole kind of index everything as a base word, as an anchor, may have performance limitations. But there's not any reason that you couldn't have these nodes actually just plug in something that's doing meta searches on the data, like plug in actual Elasticsearch or something like that, and have something outside of Holochain be running the indexing on the Holochain entries.
And sort of essentially have the idea of an external service, maybe something like that.
Yeah, because this is agent-centric, you as an agent can connect things in to your data locally, right? And if you are an index node, then you have all the data that needs to be indexed, and you can be indexing that locally, and then you can respond to queries using that algorithm, that kind of thing. So you can do things outside of Holochain locally. That's like the like you were talking about the machine learning for prioritizing results, that kind of stuff. This is a similar sort of thing.
But of course, you wouldn't want every user to be re-indexing, all of Facebook or even my view into Facebook. That's the big advantage that centralized systems have. They only index it once.
But for resilience, if you want a decentralized system, you probably want decentralized indexes where you might have 20 or 200 or, some number of nodes that are each independently indexing this. And then you're not relying on only one organization. Now, the question is, for that higher workload, what's their incentive to do so? Well, sometimes the data is the incentive, right? Because they want the view into the data, and they want to be able to see patterns in the data. And the idea that they would be willing to run a server and have everybody notify them when they publish new data into Holochain would be an incentive in and of itself, right? If I want to run, an index server for a ride sharing application because I'm a municipality and I want to see what the ride sharing needs are, what they indicate about where we may need transit routes or things like that, right? Like having that data for us to do analysis on could actually be useful. I would have that data if I ran an index node. If you need to pay people because you don't have useful data that nobody knows a use for, which I'm not sure if that exists, but then you could create other incentives. You could run it on like Holo hosting and actually have people hosts get paid to run index nodes.
Let's assume that, for instance, someone wants to build a competitor to Facebook or Twitter for their community, but they're concerned about privacy. So they don't want to incent somebody to mine the data in return for providing search. So was it the application builder who creates the link to the concept of search servers?
It is.
Okay.
You know how we had those different zomes or we have different microservice DNAs?
Right.
The application builder can build just a little stub of a zome that knows how to call into the other DNA, right, to send those direct messages back and forth to the index nodes. And that lets you split the work between nodes that are carrying the heavier indexing load and nodes. And similar kind of thing, not just for indexing. If you wanted to run YouTube on Holochain, you probably want to have nodes that are actually serving out video, streaming video, and nodes that want to be viewing or maybe even sometimes posting video from a phone, but they don't want to be serving video from their phone, right?
Yeah, definitely.
So similar kind of thing for a different reason where you want to break it out into two classes of nodes that are providing different levels of service. And you do that by breaking it into two DNAs that know how to talk to each other in Holochain.
Okay. Well, that sounds like you guys have done a lot of thinking. And, we know these are the hard problems in distributed computing. So you're clearly thinking about it. And we will see how it goes. I think I mentioned this originally to Fernanda, that I've actually allocated in my schedule June and July of this year to write a Holochain app.
Woohoo!
Yeah, I taught myself Rust last year in November as my new language of the year. Every year I teach myself a new computer language. Got up to the point where I could write a bit more than hello world in Rust. And I've allocated on my calendar June and July to knock out a Holochain app just for fun. So I will explore some of these issues. I'm sure I won't go quite as far as all this, but these are the kinds of things that I am interested in when I'm accessing a infrastructure ecosystem for what it can really do.
Nice.
And I'll probably write it up as a Medium post, which should be interesting. We are getting late here. We've had so much fun talking. I was going to go into validation in a major way. It's a very important concept in Holochain, as far as I've been able to ascertain in my readings. But could you talk a little bit about validation and how it really works? It seems like it's actually quite central in how one thinks about designing an app.
Yeah, it really is. It's funny. Validation is a little bit of a bugaboo in apps people write, because often when they're in the early learning curve, all they're trying to do is just make something happen, right? Like commit the data and read it back again and have other people find it, and woohoo, it's working, right? Now we're sending tweets around. And one of the things I loved to show while demonstrating the Clutter app was we get to the validation rules, and validation really is the heart of the matter. This is where peer-to-peer data integrity lives, right? And I would show them how the edit rule on a tweet would check to make sure that you were the author of the tweet, right? And so it would compare if I go to edit this tweet, or if I've submitted an edit to a tweet out there to the DHT and other nodes are validating this, they're first checking to see, am I the author of that tweet? And if I'm not, then it doesn't pass. Like I don't get to submit an update to that tweet. Only the author can update their own tweet, right? But then I would go to the next section, which was delete a tweet, and it just had return true. So it turns out we weren't validating who was deleting tweets in that app. It was just anybody could delete anybody's tweets, but anybody couldn't edit anybody's tweets. Right? And so this is the kind of the thing that creeps in is you start off by just sort of throwing a return true in the validation rules because you just want to see something happen, and then sometimes people don't get around to putting in all the right kind of permissions or enforcement in the validation. And actually in the tools that Philip's been working on, he's calling it CRISPR, because it's for slicing and dicing Holochain DNAs. We've sort of abstracted basic permissions down so that we can we have a plugin with a roles module, and you can actually define some different roles and then put permissions in there. And we'll even fill out some of those things for you so that you can constrain something to the author only, or to an admin group, or to other roles that you might create in the system. So we are trying to help people even generate their validation rules, because permissions is certainly one of it, but also business logic. Like, do you have the credits you're spending? We can't help you automate that. You're going to have to do the logic of summing the old transactions and seeing what the current balance is, for example.
Yeah, though at some point, presumably like every ecosystem, there will be modules to do that for you, right? Think about the Python ecosystem.
Yeah.
The reason the Python ecosystem, I use it for a surprisingly large amount of stuff, not because I particularly love the Python language, so I think it's okay, but because there's a bazillion modules available to do almost anything. And I think that's going to be real important if your ecosystem is going to take off, is to find reusable code that people can bootstrap up to high levels of functionality without having to write too much stuff themselves.
Exactly.
It's very important. I got a bunch of other little things here, but I want to get to the bigger picture stuff. But before I do that, one critique, in fact, I think I actually dinged you guys on a podcast back in October. I'd stumbled across Holochain last year, maybe August. Somebody said, hey, you should check out Holochain. That looks interesting. You'd like it. And I did. And I said, wow, this is interesting. And then I reached out to two of my experts on blockchain-related things, distributed computing more generally. And both of them said the same thing, which was, damn set of good ideas, but I think they killed themselves when they switched from their Go platform to their Rust platform. They lost too much time, lost too much velocity. The world's going to pass them by. How would you respond to that now, 8 months later?
They may have even gotten that information from one of my own blog posts where I questioned whether we really screwed that up, because our prototype version of Holochain in Go was surprisingly functional and mature. Like it wasn't built with hardened security from the outset, so we didn't really want to encourage people to run kind of enterprise level stuff on it. We kind of downplayed its readiness, but meanwhile, it worked really well. And when we went to re-implement in Rust, there were a lot of hurdles. Rust is a very strict language, and we were sort of willing to bite the bullet on that because the idea is we wanted to make something more hardened and strict and that we could stand behind the security of, and that spending time dealing with that strictness up front may save you a lot of the security pains later from introducing whatever memory leaks, vulnerabilities, reentrant code, different kinds of problems that are especially challenging in distributed systems, distributed applications. And so there was that, and there's the kind of maturity of Rust and the Rust ecosystem and the level of tools that were available and how they kept changing under our own feet as we were trying to use them. But even worse, we tried to use WASM, or we were using WASM WebAssembly. So we were compiling Rust to WebAssembly, or app would run in WebAssembly. The idea being we wanted to be able to make this to be able to run in people's browsers and stuff, and really bring the peer-to-peer web right into browsers. And we were targeting a relationship with Mozilla in that as well, although that hasn't advanced very, very far for a lot of reasons. But we just had this idea of like being able to actually run Holochain apps right in your browser and not need servers at all anymore. And boom, we've just made it super easy and easy to adopt. And we've completely eliminated that threshold, that barrier that is like in the way of getting into blockchain apps and such. But WASM was a black box. It created a black box, but you couldn't really like debug the problems that were happening. We had memory management problems. We didn't really even know how to manage WASM's memory effectively. We would spawn more instances of WASM. We'd end up using a lot more memory than we, in retrospect, now needed to. So we've learned a lot in this process, but it was definitely a huge delay. And we implemented a bunch of these things, I think, using a pattern that was kind of an anti-pattern for Holochain, and that we were experimenting with running Redux as our state model in the local state system. And I think that tripped us up in a bunch of ways as well. We actually have done a reset to a Holochain state model, and things are moving much faster, clearer, and I would expect to see somewhere on the order of magnitude of 10,000 to 100,000 times performance increase from this refactor. But I think we lost a lot of steam. We lost a lot of momentum in that process. And I do regret now not actually taking the Go prototype and building more of an ecosystem around it, and having, instead of it being kind of the mainstream track, having it be more like a Skunkworks track to do the Rust refactor, where we come out with a more hardened version, but we wouldn't put all of our attention on that. Problem was, we wanted to build something that required the hardened security. And yeah.
Yeah, well, keep in mind, as we talked about earlier, HTTP, HTML, they were just piles of shit, right? Terrible.
Yeah.
But they somehow managed to build a whole empire. So yeah, I guess time will tell whether that was a fatally wrong decision or not.
Yeah.
Do you feel now that it's reasonable for developers to start looking at Holochain and your ecosystem to build real stuff with?
I do. We haven't actually released the refactored core yet, but it will be highly compatible with the existing one and much more performant. So you can write apps now that will not need to change much to run on the refactored core. So I think we're actually ready for that. And we've been putting it through the paces. And unfortunately, that's also been some of our delays in launching the Holo hosting network, is really hardening Holochain before we can actually run a real hosting network on top of it. because there's these two separate projects, Holo as a hosting network and Holochain, which is just an open source peer-to-peer dApp platform, essentially. And people confuse the two a lot because people assume that Holochain has a currency, for example, and it doesn't, but the Holo hosting network does. And so people conflate the two.
Okay. Well, that's a perfect transition because that's my next topic on my list. As we kind of wrap up, having talked about Holochain in moderate depth, think enough for people to get a good sense of what it's about. Let's go there. As I was doing my research, I discovered, okay, we have Holochain, but we also have Holo, HoloFuels, HoloPort, etc. Pop up a level and talk about the ecosystem that you're building around Holochain and the various parts and what they do.
Well, we really had a commitment to try to bring P2P computing to the mainstream. And for us, that means being able to serve people right now the way they use the web, where they can click on a link or type a domain name, do a search, right? And something comes up in their browser, and they don't have to know that they're dealing with sort of next-gen distributed tech yet. They can dip their toes in the water and use it as a thin client where somebody else is kind of providing the peer hosting for them. Sorry, let me back up and just say Holochain doesn't have a built-in currency because we believe that we've segmented the problem space in a way that you're only carrying a load you want to carry. You're only running an app you want to run, like we were talking about your company's Slack app kind of thing, right? Well, you hosting each other's data for the 50 people in your Slack team or something like that is a minor load, and you're carrying it because you need to communicate with those people. You don't have to carry a huge monolithic blockchain load of every other app in the ecosystem, right? Just your own. And even that one can be sharded and broken up into smaller pieces, right? So we believe we already solved kind of that built-in incentive problem of people running apps. But the problem is, how do you bring in a mainstream user that isn't going to install some next-gen peer-to-peer crypto app? And that means they're just going to consume it on a web browser, which means they're not kind of sharing the load, which is the way Holochain is built. It's built to share the load among the users. And so then that means one of these other users kind of has to take on an extra load for the web user. And that's where the Holo peer hosting network really kind of comes into being, and why it came into being is a way to be able to take this stuff really mainstream and have the experience be like you type in your email and a password and you think you're logging in. You are sort of. What you're really doing is using that to generate keys, and you're stepping into a world where you're now managing your own private keys and dealing with cryptographic applications that are decentralized, but we're hiding all of that so that it just gives you the mainstream experience of using a website.
Got it.
And I think that's critical for this stuff to be able to go mainstream. And it's a huge industry, right? Like the whole cloud hosting industry, being able to host applications on peer networks and not give all your data over to Amazon or Google or whoever it is that, makes it easy for the NSA or whoever needs to come and file a subpoena to access your data, like you're still putting it all in the centralized places, even though theoretically you control those virtual servers, right? They're still under their control. And this creates a way of actually having a resilient framework that the community holds itself.
So let me ask a question. I think I know the answer based on reading the material on your websites. You described Holo as an Airbnb for Holochain apps. So does that mean that Holo itself will not actually have servers, but is essentially a switching system for other people's compute capacity? Or will you have some of your own servers, or will it be a hybrid?
Yeah. So, Airbnb sells more room nights, or did. I don't know what the current status of things are during pandemic, but was selling more room nights than the largest hotel chains, but never built a hotel. We believe that in the direction that things are going toward more distributed dApps and that kind of thing, applications, that we could host on scale massive infrastructure without ever building a data center, without by being able to tap into computing power where it is, just like Airbnb taps into rooms and homes and things where they already are. Does that mean we will have no servers? No, there are some infrastructure parts that are still centralized for Holo hosting. Holochain is way completely decentralized. Holo hosting, you still have to do things like resolve domain names, which means there has to be an authority for DNS. And now we have taken the centralized parts of Holo and we're running most of those on Cloudflare's infrastructure through their service workers and key value stores. So even those centralized parts are split across thousands of servers on Cloudflare's 190 data centers, and super performant, super fast, because we want to, again, give as close an experience as we can to just using a website. And so if we can resolve the domain name quickly, route you to a host quickly, then if that host has a slightly slower connection, at least the process of getting there was as fast as we could make it. And now you're getting some data served out to you from a peer host, right? And we're trying to make this as seamless as possible to a web browsing experience.
Okay, let me just ask a scenario. I happen to have a couple of surprisingly fast, surprisingly cheap servers I bought off eBay one time. I think they got 8 processors each and 4 cores each. So it's kind of crazy what they'll do for a few $100. Could I somehow put that compute pool to work without having to worry about anything much and get paid for running my machines, and you presumably running Holochain apps on that infrastructure? How would that work?
Yeah, so that's where the currency comes in that I mentioned earlier, is that there is an accounting system essentially for that host power. So how that works is, yes, you can run that on your machines. We also sold little devices that look a little bit like Mac Minis. They're small devices that you can put on a shelf and plug into your internet router and host these things from home. The idea there was it's kind of a plug and play system. You have to it comes with a USB drive. You plug in, you go to a website and basically configure your keys. And that all happens locally. We don't know anything about your keys, but you go to the website to pull down the software that writes those keys to the USB drive. You plug that into the Holo port and boot it up. And now you have a server running on the Holo network. And you could do the same thing with your boxes you bought on eBay. You don't have to buy our hardware. But you do, at this stage, have to run Holoport OS, which is a Nix OS build that is how we're distributing the hosting framework right now. And it loads up Holochain and sets up the tools for being able to install hosted apps and all that kind of thing. And the problem is that we shipped out those Holoports in January, and here we are in April, almost end of April, and the Holo hosting network is not publicly available yet. We've been still running tests behind the scenes and having some performance glitches and stuff. As you may know, distributed systems are hard, and debugging distributed systems is hard. And so we actually haven't opened the hosting network up to the public yet, but that is the intention.
Imagine some of those people that bought those Holo ports aren't too happy.
Yeah, I imagine so. I mean, we know so.
Yeah, and presumably they were buying them for the purpose of getting paid to host apps. Is that pretty much why they bought them?
Yeah, certainly some were. A lot were really excited about the vision. I mean, we have a core community that is really excited about where we're coming from in what we're doing, and very supportive of what we're doing and supportive of the pure hosted web vision. And yes, it'd be great to get paid in some crypto, but I don't think anybody thought I'm going to make my living off of running one little Mac Mini style device connected to my internet router. Because if you could, then everybody would do it, and then
price would get bid down, and you'd be making 11 cents a month, right?
Exactly.
Just for my own information, because I am going to build a Holochain app, is there some benefit to having a Holo port to host my own app?
Well, the way that I envision this, and this is that yes, you can put self-hosted apps on your own Holoport, if you will, on your Holoport OS. So the idea is that you could handshake between some of your other devices, say your laptop and your phone and your Holoport, and the Holoport then kind of becomes your own personal secure data backup of the things that you have going on your phone and laptop. And then you don't have to worry if your laptop gets stolen or your phone gets lost or drops into the toilet or whatever, right? With the key management, if it got stolen, you can revoke the keys and make a new set and pull things from your like Holoport as your own personal data backup and regenerate your state. You get what I'm saying, right? I don't need to go on with the examples, but there's a reason to have sort of like your own little stable box that doesn't get stolen when your backpack gets stolen or whatever.
Yeah, gotcha. And I can still peer with other people, whether they have Holoports or not, right, et cetera. Okay, that's good. So I think I'll get me a Holoport when I start playing with this stuff. And besides, you know me, I'm a hopeless techie. I always like to play with something new. Let's go on to another topic, which I think there's a little bit of confusion about. I'm still confused, to tell you the truth. What is the difference between HoloFuel, which seems to be the currency for paying for Holo distributed serving capability, and your hot ERC20 token?
So HoloFuel runs on Holochain and powers the Holo hosting network and needs to be tuned in terms of its performance and price overhead to be able to do somewhere on the order of magnitude of millions, if not billions, of transactions a day. We're running a hosting network. If you have, let's say, 250 hosts serving your app, and you have, thousands of users coming in, they're getting routed out to these different hosts. Those hosts are racking up small amounts of hosting that they sign to their hash chain. They sign an immutable log kind of record with back and forth handshakes with the Holo client that the web browser is actually using for making the requests. It's just running in their little JavaScript layer that's signing their requests, right? So that you end up with a log that they can provide as proof of service, essentially, that they were serving your app. And that then becomes an invoice that you as an app provider, instead of paying Amazon for hosting services, you're paying this peer network for hosting services. And they send in this invoice, which gives you access to the log. So one of the things that, I don't know if you're thinking about, but you have no idea what levels of traffic are even happening on your website in a peer hosted system, unless you have a way of collecting this data to a centralized point, right? So the fact that they invoice you, what they do is they give you a little key that lets you collect their service log for the services, and then you can do your fraud detection on it or whatever that you want to do to make sure that they did the work. But most importantly, it gives you the data of the activity levels and what's happening in your app. Otherwise, how would you even know what's happening in a peer hosted app, right? Like, you don't have central logs anymore.
And of course, we know logs are important for, go on.
For tuning and troubleshooting and feedback and what people like and what they don't and what's working and what's not. Like, you need this data for a lot of things, right? Anyway, so the HoloFuel is for powering that network. We need to be able to do very small transactions with low validation overhead in high volume. So in other words, as you know, like you've railed before against the cost of Bitcoin. Like, the cost of one Bitcoin transaction is like 5 American households worth of electricity for 5 days or whatever the thing is, right? It's massive. We can't afford that cost for each one of these HoloFuel transactions. We have to build a system that is highly efficient. And I don't mean cost even in terms of a transaction fee. I just mean overall system cost, right? Because we're doing small micro transactions. So we're tuning the currency to be a microcurrency. And there's probably going to be a cap on the size of transaction you can do in HoloFuel, because the validation security behind it is only sort of up to a certain level. There are certain types of attacks that if you wanted to invest a chunk of money and building a parallel computing network and that kind of thing, that you could try to do on HoloFuel. But if you can only do that for a $1 or $10 transaction, it's not worth spending thousands of dollars building a competing network to falsify a $10 transaction, right? So that's HoloFuel. The hot token was something that we did a community offering of as a placeholder, and we'll swap 1-to-1 into HoloFuel as the HoloFuel actually goes into its beta launch and the Holo hosting network goes into its beta launch. those are the two different things. So Holo token is an ERC20 token that lives out there on exchanges and is the temporary thing. And as you mentioned in that other project, has attracted a lot of people that, love or hate us depending on whether the market is up or the market is down. But I don't think that's our core community as much.
Yeah, I mean, and you literally are going to do a one-to-one exchange when HoloFuel goes live, so anyone can convert a hot token to one HoloFuel token.
Yeah, there's going to be a swap window, at least a 6-month period where it's a one-to-one redemption.
Okay. Now, interestingly, at least in my view, I'm having someone who thought about this at least a little bit. You may want to think differently about things like price stability on something like HoloFuel versus a typical ERC20 token, which is frankly mostly speculative. Have you thought about how you want the price of HoloFuel to vary over time? Do you want it to be stable, deflationary, inflationary? Do you have a view about that? Or I think you do. You've designed 100 currencies. I imagine you have a view about that.
Yeah, as you know, I'm a currency geek, and part of what we were setting out to do with HoloFuel is to provide some healthy examples to the largely what I view as unhealthy speculative patterns that are out there. The kind of sort of tokenomics people have gotten in their head of just you create a bunch of stuff and try to then kind of hype it into people believing it has value. And then, some people get burned and some people get rich. And, it's not a very safe space for mainstream business to operate, though. If I accept payment this week and the bottom might fall out 50% and I can't pay my rent next week in it, right? That's a problem for most businesses that are not in the speculation game, that are not in the speculation business. So HoloFuel is designed to be anti-volatile. I would say value stable, but people then think stablecoin now. They think it's fixed to an external currency. It's not fixed to an external currency, but it's driven by feedback loops based on the cost of providing hosting that the hosts have. And there's real costs, electricity, bandwidth, hardware. And so that's going to create a real operating range for which the HoloFuel pricing is driven by. And I don't know if you really want to get into all of the currency dynamics here, but it's definitely designed to be a very different kind of currency than the norm.
Yeah. Okay. That's good. And I think that's probably a good place to wrap this up. I still have some other things to talk about. And frankly, I'm a currency geek too, actually. I've spent 8 years studying alternative currencies and actually designed a couple. I'd love to have you back on sometime just to talk about currency. Would you like to do that?
Love to do that.
Okay, we'll do it.
Maybe that's also the space for Fernanda to be more included in the conversation. Yeah,
sorry, Fernanda, we kind of geeked out a little bit more than I thought we might, but hey, that's the way it goes. That's what I like about podcasts. They are what they are.
I know, it was great. You went really deep into great questions, and the flow was really beautiful, and so I got highly entertained.
Well, thank you for being an entertained audience. Hopefully our actual audience will be as well entertained. So thank you both, Art and Fernanda, for which I think will be a very interesting episode.
Awesome. Thanks, Jim.
Production services and audio editing by Jared Janes Consulting. Music by Tom Muller at modernspacemusic.com.